Okay, ready? Who are you guys?
We are from Missouri University of Science and Technology, and we are the Miners in Space organization.
Okay.
Our experiment is testing the thruster system of our satellite team's satellite.
Okay.
So the thruster uses a cold gas propellant system, and it runs off R134A.
Okay.
So what we have here is we've got this tank, which has a propellant management device inside it to keep the propellant from cooling up or creating a ball inside the tank when it's in zero gravity. And that's hooked up to a pressure transducer and a solenoid valve, and it runs through here, goes through a line heater and a pressure regulator, through another pressure transducer, and it goes up here to the thruster of the satellite, which is mounted on this air bearing. So how the experiment works is the thruster will thrust, pushing the air bearing that way into the load cell, and from that data we can determine if we're getting consistent thrust from the thruster to see if the propellant management device within the tank is working correctly.
By propellant management device, you mean?
It's basically how this was explained to me is it's like a bunch of screens, basically, like kind of like the screen on your screen door. So it creates a bunch of little pockets of gas instead of one big pocket.
Okay.
It's designed for butane, and it's meant to sort out the liquid from the gas. Because you don't want liquid going through the line, we want a gas exiting. So it wants to use surface tension of the liquid to hold all the butane, or what we're using, R134A, to hold it back and only let gas flow through the line.
Is the R134A a stand-in for this test, or is that the actual propellant going to be used?
It's going to be a groundbreaking thing, and there's actually a couple other universities trying this out. Obviously they're not here today, but for this week. But it's like kind of a groundbreaking thing among us and a couple other universities.
Do you have some sort of supply of like pure R134A, or do you get it out of the cans from AutoZone?
We'll use the pure stuff on the real satellite, but we determined that the cans from AutoZone work just fine for this experiment. Because the primary thing is we're testing the propellant management device, and the secondary thing that we're testing is what kind of thrust we get off just a single thruster.
Okay. What level of thrust do you expect?
Basically, we can compare it to the weight of about 4 paper clips in your hand. So 0.00 ...
Okay. Okay. So the rest of your apparatus here. Looks like you got a few computers.
Yeah, we've got the battery backup and power regulator on top there, which keeps the power clean and free from any spikes, and if we lose power, it's got a battery that'll keep the system running for a little bit. And then we have computer running regular Windows, and the program, the software that runs it all is written in LabVIEW.
Okay.
And then next to that is the DAQ, which is the data acquisition unit, which is where all the sensors hook up into, which talks to the computer.
Okay. Tell me a little bit more about the satellite it's going up, the ultimate system's going up on.
Well, basically it's through the Air Force's nano satellite competition, and the goal is to build a satellite using off-the-shelf components. And they run in a 2-year competition cycle, and they just started a new cycle, and I believe the current plan for the satellite is to have 2 satellites actually. And one is just kind of just a normal satellite, but the other one will chase it, and their goal is to keep the satellites aligned with each other and to be able to talk to each other in space.
Is it a CubeSat form factor, or is it whatever?
It's custom.
Okay. And when is that expected to launch?
Well, it only launches if they win the competition, because the winner of the competition gets a free ride up as a secondary payload. So I guess in a year and a half, if they win, then they'll be put somewhere into the launch queue. It probably takes a few years for them to actually go up.
Okay.
And this is the actual tank from the satellite, and they use thrusters similar to this one. This is just a leftover one. They've actually got 12 thrusters mounted all over the satellite to control.
Okay. Anything else you want to particularly show me?
I think that's about it.
Can't really think of anything.
Okay, thank you very much.
Yep.
Thank you.